Good morning. Today we will discuss bubble sort. In this session, we will discuss our first sorting algorithm. Bubble sort is very basic sorting technique. Bubble sort and selection sort are the very similar sorting techniques. So in this video, we will simply discuss the bubble sort only. In this sorting technique, largest element is bubbled up. Comparison in bubble sort and selection sort, if we compare both of the algorithms, then there is no big difference. In bubble sort, find the largest element and place it at the last position. But in selection sort, find the minimum element and place it in the first position. So there is no big difference. First I will discuss in detail bubble sort. Bubble sort, in this sort, adjacent items are compared. If they are not in order, then swap them. Several passes are required to sort whole array. In first pass, only largest element bubbled up. In second pass, second largest element, and so on. And finally, there is no mean to compare the last element, that will automatically be at the first position. This is the example of bubble sort. And you can understand the concept how we apply bubble sort. If most of you are familiar with the other sorting algorithms, then I will tell you it doesn't matter. So generally we use this bubble sort as a starting or the basic sorting algorithm to understand the concept of sorting. Following operations are required: traversing the array, compare pairwise elements. If not in order, then apply swapping. Repeat this process till largest element is shifted to the end. So here we are taking the example 40, 20, 30, 50 and 10. There are 5 elements in the given array. So we will start from the beginning and compare with the next element. So this is called adjacent elements. So first we have to compare these two elements. If they are in order, then there is no need to swap. Suppose 40 and 20. If we want to sort the given array into ascending order, then this is not the order. So 20 should be at position first and 40 should be at position second. So how? First we have to compare this adjacent element, then swap it. So after swapping, 20 comes here and 40 comes here. The swapping is done. Now again, in next step, compare next two adjacent element. If they are in order, they are also not in order, then swap them. After swapping, 30 comes at position first and 40 comes at position, or you can say index number second. Now similarly, compare next two adjacent elements 40 and 50. They are sorted because 40 is less than 50, no need to swap. So now move on, next cell. Here 50 is again greater than 10, so we have to apply the swapping. So this is the complete one iteration, and you can see the largest element is shifted to the end of the given array. So the steps are very simple. We have to repeat this step again. Then in next iteration, what will be shifted? The second largest, that is 40. So now the array size in second iteration reduced by 1. So now in first iteration there were 5 elements and 1, 2, 3, 4 comparisons were there. Now only 3 comparisons are required and size becomes 1 less than the previous size. Here you can see this is the first iteration. In first iteration, the 50 shifted to the end. In second iteration, 40 shifted to the end and the second position. And third iteration, 30 comes on this second position. In fourth iteration, 20 comes on the first position. And automatically the smallest element comes on the 0th position. Now you can see there were total 5 elements 1, 2, 3, 4, 5. So total iterations or the passes are required n minus 1. These are 4. 1, 2, 3, 4. Another thing is how many comparisons are required at each iteration. Here you can see in the first iteration the required 4 comparisons in this first, second, third, fourth. In the first iteration, 4 comparisons are required. In the second iteration, 1, 2, 3 comparisons are required. In third iteration, 1, 2 comparisons are required. In fourth iteration, only 1 comparison is required. In last, automatically the resulting or the sorted array is there. And this is the very simple code of bubble sort. Int address of the base address of the array, given array. Int n, this is the size of the array. These are the basic variables. So we are taking the first for loop. We can take either I, j, k, whatever you require. I am taking the variable pass. So pass means total how many passes are required. So 1 to n minus 1 means total elements were 5. So 1 to 4. Total n minus 1 iterations are required. For second loop, it will compare 0 to j less than n minus passes. In first time, 5 elements were there. Second time, 4 elements were there. In third iteration, every iteration, the size of array is reducing, so it is decreasing. So we are just subtracting the value of pass. First time, it will execute for 0 to n is suppose 5 and pass is starting 1. So 5 minus 1, that is 4. So 0 to 4. So 0, 1, 2, 3. Clear? Then second time, it will execute from 0 to n minus 2. So n is suppose 5. So 0, 1, 2, 3. Clear? So this is a very simple process. And if aj, the first element, is greater than the second one, then only swapping is required. Otherwise, it will do nothing. So now come to the drawback of this bubble sort. What happened if array is sorted? If array is given in starting array sorted, if we apply bubble sort, total n minus 1 iterations are required whether it is sorted or not sorted. So this is the drawback. It will take the full time. What happened if some elements are not in order, but after a couple of passes the entire array becomes sorted? Suppose after 1 or 2 executions of 1 or 2 iterations and array becomes sorted, but it will goes to the end. It will take the full time. So to save computation time, we need some other corrections or refinements to improve the existing bubble sort algorithm. So I will tell you, if you can do it, then try it, how we can improve the bubble sort, existing bubble sort, how we can check the condition whether it is sorted. If the input is already sorted, then there is no need to execute all the loops. So how we can terminate? Think about it. I'm just taking one example. Suppose this is the array, given array. In starting, 4 comparisons are required. It's okay. 50 comes in the last position. But in second pass, when we compare these elements, these swaps, these elements are swapped and 10 comes here, 20 comes here, 30 comes here and 40 comes here. Then you see the resulting array is sorted. There is no need to go for third or the fourth iteration. So how we can check this runtime? If the array is sorted, then there is no need to go further. How we can stop here? So we have to think about it. How we can improve this bubble sort? So this is assignment to all the students. If you can do, that's okay. If you are not able to improve this algorithm, or you can remove this drawback, then you should, I think you should go for my next video, that is tutorial video, in which I will discuss the code of bubble sort, as well as I will discuss the solution how we can improve this bubble sort. This is the time complexity of bubble sort in best case, worst case and average case. In all the cases, suppose element, if overall array is given sorted, then it will take O of n square time. If it is reverse sorted, then it will take O of n square time. In any case, it will take O of n square time. Thank you and best of luck. See you in the next video.